Okay, let's talk about the leader follower patterns. In the distributed systems, uh, these pattern helps. Okay, so many places you can say these leader follower patterns are very useful, basically in the distributed system designs. So as I mentioned, this pattern, leader follower patterns, in is a distributed system design patterns, and that's allow multiple nodes to coordinate and maintain consistent state in the distributed environments. Right. So distributed environment, that means our uh, data stores in the multiple nodes, multiple server, multiple geographical locations. Okay, so the objective of this pattern is that they are going to allow or help to ensure that the data between the multiple servers are synced properly, maintain the same state. Whatever the data state in this server, same would be here, same would be here, same would be here, same would be here, same would be here. So make data consistency. So this is the one patterns through help us we can ensure that our data that are in the multiple server, different server, different databases, or different file systems. We are going to ensure that every data have the latest and updated copy. Okay, so in this pattern what we did, one node is designated as a leader. So because there's multiple nodes, so let's keep one as selected, this is selected as a leader, and other all nodes called as a followers. Due to that, say leaders and follower patterns, and replicate the leader states and follow its instruction. So all the nodes which are the follower are follow the same instruction as leader and sync, replicate all the states of the leader. So this is the leader follower pattern. That means in the distributed environments where multiple our node servers where I have multiple data. So if one node is selected as a leader and this leader's state is replicated to all his follower nodes. These are some basic concepts before jumping the details. So, what do you mean by leader here? What do you mean by follower and replications and consensus? These are the basic terminology whenever you are going to understand the leader follower patterns. So, leader node is responsible for maintaining the primary copy of the system state and making decision on the behalf of system. So, you can say whatever the leader node or the leader data center, okay, and every other nodes, okay, okay. So, overall the system state is considered as a primary node, primary data, true, actual true is the primary node. Primary node here considered as a leader, and all the anything change happen, anything modification happen, anything delete happen, these states are going to replicate to all its the follower. So you can say follower follow its leader. But the follower needs replicates its leader state and apply the leader decision to its local state. So whatever the leader's state have it. So follower is responsibility to follow the leader. That means ki whatever the states on the leader node, they are going to replicate on its local as well as. And whatever the instructions given by leaders, follower also follow them. What is the replication means? Replication means replaces the process of maintaining multiple copy of a system state across the node. So replication means whatever the data we have in one data server, I am going to replicate in the multiple data server. Multiple data server. The same copy are going to replicate here, same copy going to replicate here, same copy going to replicate. So this is the replication is the process where the same copy of data we are going to put in the different location, different server, so we can maintain the fault tolerance, we can maintain the scalability issue, we can lots of benefit about this. Okay, so here the leaders and follower pattern ensure that if the same data are we are decided to put in the many different different data server, so how it's possible if let's something change happen here new data modification happen, so this new data should be replicated to everyone. So here, if this leader is the primary node, leader node, so all the forward are going to replicate the same state on a local library. So in this patterns, we are ensuring that our data is going to consistent across the all the data nodes, all the servers. And what is the consensus? This is a process of achieving the agreement among the nodes of the state. So this is the kind of mutual understanding between all these nodes who are become a leaders. Okay, so leader can be, you can decide. There are lots of algorithm. Consensus is a one type of agreement between the nodes. That's hey, this is the system state, or this is the who is the represent the system state, who is represent the primary node. So this is the consensus algorithm approach where we are deciding, hey, this node is become the leader node, and our rest become the follower nodes. That's this represent to complete system. Anything, any statement, any update, any modification happen on its leader node or primary nodes, all its follower are secondary node responsible to replicate the same state on its local state service. So this is the basics of the leader follower patterns in the distributed system designs. So these are the very basic architectures where the leader is to become a centralized concept. That means whatever the leader node we have selected a primary node, this is a kind of centralized. This represents the complete states of my system. Okay, and one is the decentralized leader. That means one node is designated as a leader and all follower is the connector. Another is the decentralized leader. Means each node can become a leader, follower connect to the current leader. So here, whatever the node we have, whatever the set of nodes or set of server data server have, so possibility is that any node can become a leader. That means we have not very fixed, hey, this is the only primary node, because each node are capable to play a role of the primary node. So how this happen? How we are going to decide which node become a primary node? Because each node is capable to manage or play a role as a leader. So this is known as a leader elections. So the process to select the new leader when the current leader fail or become unavailable. So this is a scenario. Hey, we have a lots of our data nodes. So all this is that's leader, and these are the follower. These are the follower. These are the follower. These are the follower. So currently everything's happened properly. Whatever the data state change in the leader, a primary node, all the followers are replicated the primary state to is a local store. That's great. What happened is my primary node or leader somehow fail or disconnected or fault happened. So the remaining followers, because these followers are very capable to play a role of leader, but currently there is no leader, so we have to again between these four they are going to make the leader election. That's who are going to become a leader. With the help of consensus algorithms, Any one of can become a leader. Let this become a leader. Now leader are going to become a primary node, and primary node state going to replicate by all its follow. So here you can say this is a very common sense that if our leader node is not available, a primary node not available, others nodes, other follower can become a leader. And these are the approaches, the multiple, where we can achieve this follower leader follower patterns. Maybe you can go with the master slave applications, or you can go with the multi-master applications, or you go in the leader based consensus, or you can say leaderless consensus. So there are multiple approach available where we can implement, we can develop these leader follower patterns in the distributed system, where our data are we are designing to store on the multiples node, multiple location, multiple region. Okay, so the objective of this leader follower pattern is that whatever the leader node state is, the same state is going to replicate its all the follower. So everyone can just replicate data. Everyone can replicate data. Everyone can replicate data. Everyone can replicate data. So one node would be your leader node, and all node become your follower node. Follower node. Follower node responsible to replicate its states as the leader. Means leaders, whatever leader instruction, whatever the leader state, every follower can follow. And each and every follower node are very capable to become a leader node if in case of any unwanted happen, leader crash or some failure happen. So all the follower node due to the election leader election process can be selected another leaders. These are very basic, so you can say the process approaches where we can maintain uh, same data in the multiple nodes. So maybe one leader maintain the primary copy of the data, and follower need to replicate the data. Simply, you can use the MySQL master slave. That means this is a one data base. This is the very our master database, and multiples you can say our slave databases. Slave. Okay, all the transaction happen through the master. If any new record come, they are going to replicate. Every leader follower going to replicate. New data going to update some happen. Every leader going to update his state. Some record deleted. Every follower node going to replicate. So one is considered as a master node, and all considered as a slave node. The slave means here all are the follower. Master means here the leader. And MySQL all support this master slave replication strategy. You can use a database replication or caching strategy. Multiple places where you want to place same data of the multiple copy of the same data. So in the maybe file system, maybe caching system, maybe database, where this master slave replication help us. And sometimes instead of the only one become a master, so there are multiple leader node maintain the separate copy of the data, and follower replicates the data from each leader. So might be case we have a multiple leaders available, and some are the followers. Okay, so they have might be this leader and this leader. They have some update new data. They have some data. So all the followers are responsible to replicate data from the both leader, from both leader, from both leader. Okay. So this is known as a multi-master replication. The objective is that we can enhance our capability. That means your multiple nodes are play a role as a master. Means they can receive the read request, write request, everything, and they can then multiple leaders are responsible to hey ensure that all my followers can sync, replicate his data. So generally, where the in the distributed database, or you can say all the real-time data processing might be the single master is not more efficient instead of multi-master replications. We are going to the place to support real-time data processes. And some places you are the things approach like leader based consensus, like the leader node propose, update the system state, and follower agree or disagree. Might be you can say Raft consensus algorithm. Lots of consensus algorithms have where the follower or leaders how are agree or disagree on some particular updates, some particular states. And generally, all the distributed system where you want to your system very manage fault tolerant systems where the leader based consensus are play a very good roles. And we have another approach without maybe leaderless consensus approach. That means no single leader node. Instead, nodes agree on the system state through the consensus algorithm. Just we say, hey, there is no leader. All the nodes, whatever the nodes have, each nodes are going to agree how we are going to replicate data, how we're going to sync data with the help of just consensus algorithm. Just say, hey, this is a consensus algorithm, maybe like a blockchain technology, where there is even a centralized master kind of things. This is the where the your cryptocurrency are all the decentralized applications where there's not only one masters or leader that can manage, that can represent the complete state. Hey, just we have some set of algorithm available. Every node considered as a uh, primary nodes, and the responsibility of all other primary nodes are considered as a follower kind of things. You can say everyone leader, everyone considered as a follower. There is a no distinction between the this is the leader or follower. Means each node play a role of leaders as well as follower. From anywhere we can start to updating, getting, and every nodes are responsible to replicating his states to all other leaders, all other followers. You can say. And blockchain technology is a very, very good example where there is a centralized where your transaction can be started, who is the governing them. Very, very distributed kind of applications where there is a no leader, leaderless consensus. Means ki only the algorithm, only the particular consensus algorithm play a critical role, some hashing function on the basis of blockchain, the way the system is designed. So these are the places where in the distributed system, multiple data center, multiple storage location, where you want to ensure that each and every uh, nodes have a same updated and current copy of the data. And these the patterns, leader and follower patterns, if we properly with the help of any approaches, whatever you think in nature of your applications, because by our systems become get this benefit, like your system become manage, handle fault tolerance, and your system become highly available, and your system can be scaled because we have a just like a one node, two node, three node. Each nodes have a same copy of data. If system load is going to increase, we can make one more copy. We can add one more server. We can add more server, and all are going to replicate the same copy. So you can say our system can very scale because we are distributed systems, and these are the highly available because we have a providing multiple server, multiple same data. If one node may be fault not happen, other node can serve the request, other node can serve the request, other node can serve the request. So fault tolerance, our system is very fault. Something fault happen, still our system is able to reply. Due to that, we can say our system is very highly available. Okay, because we have a same data in the different location, different center, multiple copy. Might be have multiple copy. One data server, one data center are fault or problem happen. Maybe same data available on the nearest data center. Our application going to responsive from the other. So you can say if we are properly implement this distributed pattern like leader follower patterns, so our system very become the manage handle fault tolerance, and our system can very scalable depend upon the user traffic load, and we are also ensuring that our system is highly available, because if your system is very scalable, that means system is can be highly available as well, and you are manage the fault tolerance due to the your multiple copy of the data in the different location, geographical data server, multiple copies. So these are the some kind of challenges, limitation, that means while the implementing these leader follower patterns, be carefully choose be carefully keep on the some specific concerns of these. Okay, you have to while the leader elections. Selecting a new leader in the decentralized system can be challenging and may lead the conflicts. So you have to properly uh, implement the approach. Let's keep multiples your follower are available, follower, and your leaders are somehow destroyed or crashed. So every follower going to apply the leader election process. Might be here say this is I am a leader become, I am leader become. So that is the confusion. If any conflict happen, if all the followers are not going to designated only one specific leader node, that may lead a conflict. So we have to properly place the leader election process so that the leader election is selected by the mutual consensus algorithms. That way help us your consensus. So achieving consensus among the node that can be time consuming, may lead delay. So whenever you are going to apply some consensus algorithm, so algorithm play take some role, take some time to process them and decide them under lots of attributes. So it will time consuming. So that might be give some delay in your leader selection process. We also thinks our what happen if your network partition means your network is break, your cable is break, your system is not able to communicate to other system, and let's say one follower is not able to communicate to the leader. So how those followers are going to the sync? So we have to properly check if a network is partition. Might be system, yes, some follower can be unavailable, due to that data become inconsistent state. So we carefully think while going to apply this distributed patterns, and always be ready, because in the distributed environment your system is a very normal server with a limited capacity, with a limited RAM. There is not very sophisticated high costly server, so fault can be happen. So please ensure that any fault happen, any malicious node can be disrupted, or operate system operations maybe lead also inconsistency. So while implement the objective of leader follow pattern to ensure that in the distributed nodes, our data, our storage have a same updated copy available. If some nodes are fault, some failure happen, network failure happen, node fault happen, so data may go in inconsistent state for some period of time until we have not monitor and recover them. So good part is that we have already very well, you can say, technology, techniques, and available. And nowadays, lots of industry applications are using these leader patterns, leader forward patterns in the distributed system. Okay, might be you can select the distributed database. Maybe you can select a Cassandra or MySQL or Postgres or MongoDB. Each and every database are support the replications among the distributed node and ensure that the data consistency. The consensus algorithms, multiple algorithm, many places you can find the ZooKeeper are used, Paxos use, Raft use, many consensus algorithm available. These are the already implemented by the distributed replication server. Maybe you can think the distributed file system, maybe HDFS here. Here also the synchronizations are this pattern. And even you can go, if you want to go the cloud platform, every cloud providers, maybe AWS, Azure, Google, everyone offer this uh, replication of the data in the distributed environments, geographical location, different server. You want to replicate, put the same copy on the multiple places. So just if you are using the cloud provider, just mention, hey, this is my data center. This is my data. I am going to store this data in the this location. The number of distributed data storage you can decide. And here you can also say my replication factor. I am going to replicate same X data in the 1, 2, 3, 4 places. So accordingly, 4 copy of your data are continuous base going to replicated by the cloud provider, and cloud provider already implemented this leader follower pattern consensus algorithm, and they are highly nowadays used and customers are really using. Okay, so lots of technology for the distributed system designs are placed, and these pattern help us to ensure that our data are consistent across the multiple nodes. And if you talk about the some examples here, like Google also have a distributed logs and servers that help us to ensure that leader follower pattern ensure the consistency. So means distributed locking service are nowadays very commonly used as a open source, and many applications are using the Apache ZooKeeper. They are a coordination service that use the leader firewall pattern to manage the distributed system. So generally, whatever the distributed system, maybe file system, maybe data storage, object storage, somehow you want to make the coordination between that. So here, leader follower patterns are also used by the zookeeper. Or if you talk about the Amazon DynamoDB, this is the NoSQL database. These are also use the leader follower pattern to replicate and make data consistent across the multiple node. Even if we talk about the Kafka also support a replication. This is a messaging system that uses the leader follower patterns to replicate and manage the fault tolerance. Even Bitcoins, where I talk about the blockchain, where the cryptocurrency that use the leaderless consensus algorithms to ensure the integrity of the blockchain. So many places, many situations, different examples nowadays already have uh, available to sorry, many you can say available applications example. This is just limited. Talk about the Apache ZooKeeper, the Apache Kafka, DynamoDB, Google's, and your blockchains where the everyone, many places you can say this leader follower patterns are used. And even you could talk about the use cases like your e-commerce platforms also use the leader follower pattern to ensure the highly availability and consistency of the product information. Even in the financial systems as well, leader follower pattern ensure that integrity and consistency in the financial transaction. Even gaming platforms, you can see gaming platforms, the leader follower pattern ensure that low latency and high availability of the game states. Even all the IoT devices also follow the leader follower pattern, ensure that integrity and consistency of the sensor data, right? Also, you talk about think about the social media platform. Also, use this leader follower pattern to ensure the highly available systems and consistency for the users. And for that, if you talk about the CDN also use the leader follower pattern to ensure that our low latency and highly available content for the customer. And nowadays, database as a services does even IaaS services also use the leader follower pattern, ensure that the data is highly available and maintain the consistency among the different database instances. And all the cloud provider, you can many the cloud provider, they are providing the cloud storage, file storage, block storage, distributed file system storage. So they are also implemented the leader forward pattern to ensure the our whatever the storage they are going to customize store, they are highly available and maintain the consistency of the stored block, file, images, video. These are the, and even the real-time analytics such as applications also use the leader follower patterns so that we can maintain the low latency and the high availability system for real-time response. For real-time is our latency would be low, that means our data would be available to the near to the customer, and due to that we have to put the duplicate copy of the same data to the different geographical location. Even nowadays, if you talk about the AI, machine learning, deep learning, these are the concepts where these are all the distributed data storage kind of things where you want to ensure that the system is highly available and whatever the data uh, learned by the machine, that should be consistent. So you can say lots of use cases where you can think this leader follower patterns are really help to ensure that the data are highly available and same copy of data available updated available to every nodes. So if we talk about the some like complete this follower leader follower pattern is the one of, you can say, one of the nowadays with the help of lots of technology involvement right now, even this is a very fundamental concept in the distributed systems, and that's ensure that if your system is distributed, so this leader follower patterns help us your system you can design highly available, consistent and scalability. So these things, uh, this pattern help us to meet easily. I see your system is the highly available, system is consistent, and your scalability. And it also help us to design and build very robust fault tolerant system, because leader follower patterns are focused to whatever the system you are going to, they are handle fault tolerant system. Even nowadays, whatever the nowadays the technology continues going to evolve, still the leader follower pattern or coordination services like things will remain play a very crucial component in the distributed system. And many times any kind of a distributed system, a distributed application you are thinking, where this leader follower patterns are play a very good or very crucial role. Even the lots of new technology are going to explore or expand the new area, but whatever the happen, but this pattern, this is a pattern, this is one approach, this is the one solution where can say our distributed system can become highly available, can maintain the consistency, can be scalable, can maintain the scalable system, and our system maintain the fault tolerant systems. So this leader follower patterns is a player very crucial role in the distributed system. So that's for the today, and I hope this information is helpful for you. Thank you.